Okay, in this section we're going to pick up complex numbers, and to start with that we're going to pick up the imaginary number I. And the imaginary number I is what we write when we run into a square root of -1. So it's literally, if I had a square root of -1 show up in a problem, I would call that I. So that's all it is the name for this. I squared is a definition, so when I square this, it's the square undoes the root. It doesn't make this positive, and so that makes this -1. And then over here is just a little bit of notation stuff, that if I have a negative under a radical, I'm going to end up writing it as an I with a positive number under a radical. So that I is kind of calling attention to the fact that it was imaginary. So we have powers of I. So I to the first we would just write as I. I to the second, that was up here as definition, that would be -1. In class, I'd have you guys work together and try to figure out what the rest of these would be. So I to the third is going to be I to the second times I. So up here we have I to the second was -1 times I, so that is -I. I to the fourth is I to the second times I to the second, so that'd be -1, -1, so that would be 1. I to the fifth is going to be I to the fourth times I. I to the fourth is 1, which is really super convenient, because then this is 1 times I, so it's just I again. And then I to the fourth times I squared would be I to the sixth. I squared would be, so that's 1 times -1. So then it's -1 again. And you kind of see this pattern emerging. This will just be the same thing as I to the third, which would be -I, because this is a 1 times I to the third, which is -I. I to the fourth, so that's 1 times 1. This was 1 times -I. And then this is 1. So this pattern, this I, -1, -I1, I, -1, -I1, that just goes to infinity. So an easy way to reduce powers of I is to knock out all the groups of 4, because for every group of 4, it's really a 1. So if I have like I, that right there is just a big fancy 1. So we'll see that in this next set of problems. So here we're supposed to rewrite these kind of higher powers of I in terms of I, -1, -I, or 1, because everything reduces down to one of those 4. So I to the 17th, I can think of that as I to the fourth, I to the fourth, I to the fourth, I to the fourth, with a leftover I. And then for every one of those I's, I to the fourths, it's just a 1. So it'd be 1 times 1 times 1 times 1 times I. So this whole mess would really just equal I. We don't want to write that every time though, so an easier way to do that is just to say, how many times does 4 go into 17? So 4 goes into 17, because we're looking for groups of 4, 4 times with 1 left over. And the only one we care about is that 1 left over, because that's the one. All the rest of this was just 1s. So the 1 left over is just I to the first, or that this is I. I to the 36, so if I do this version, 4 goes into 36, 9 times, no remainder. So this is just 9 1s multiplying, so this is just a big old 1. I to the 43rd, so that I can see it's going to be I to the 40th, because 4 goes into 43 10 times. And then it doesn't go in here. So we're going to have 3 left over. So this is the same thing as I to the third. And I to the third, remember, was -I. And I to the 62nd. So if I go 4 goes into 62 once. And then 22, so 4 goes in 5 times. And so the only part we care about is right there. It's the 2. So that means this is I squared, which is -1. This next round is simplify. So this is just, this is kind of how we write the I in terms of roots, just sort of notation. So if I have square root of -25, that used to be, did not exist, but now it's actually going to be an imaginary number. So it's the same as what it would have been. Square root 25 would be 5, but now it's going to be 5i because of the negative under the radical. This one would be the negative of this last one, so it's just negative, and then 5i. Negative 28, so this is a 4 times 7 under there, if I was simplifying. And so where the I goes is sort of after the whole number, like I did here, but before the root. And so like when we have just a plain root, we write it I root 7, so that it's not confusing as to whether or not something's under the radical or not. So here the 4 comes out and there's a 2i, and then root 7. So it's the same as like if you had an x, the same place you'd put an x after the 5, you'd write this 2x root 7, and then this you'd probably write x root 7. So that's the same place the I goes. And then these ones that have you guys try. So square root negative 49 would be 7i, and then this will be negative, the 45 would be a 9 times a 5. So we're going to have a 3 come out, we're going to have an I come out because of the negative under the radical. This negative is the one in front, and then root 5 left behind. Here with the 11, 4 goes into 11 twice with 3 left over. So this is I to the third, which is negative I. And then I to the 26, so that would be 4 goes into 26 6 times with 2 left over. So this one is I squared, or negative 1. Okay, in this next part we pick up complex numbers. And so complex numbers of the form a plus bi. And so this is that same I we've been looking at. A is the real part, so it's the numbers we've been using all along, 1, 2, 3, 4, 5. And then it can have with it bi, which makes it a standard form for a complex number. And so here's an example of addition with a couple of complex numbers and subtraction. They're actually pretty intuitive for what they are. Basically, if you think of like terms, that's kind of how these operate. So the 4 plus negative 5 would go together. The real parts, we'd add those. And then the negative 7i and then the minus 2i, those would go together. We'd add the imaginary parts. So 4 plus negative 5 will make negative 1. And then this is negative 7i plus negative 2i, so that'd be negative 9i. So we're just kind of adding like terms essentially. For the subtraction, it can help to rewrite this. It's that whole thing with the parentheses and it has to be distributed, the sign there. So I'll rewrite this as negative 4 plus 2i, and then minus 6 and minus a minus to make that plus 7i. And then I'm just combining the real and imaginary parts. So negative 4 minus 6 would be minus 10, and then plus 2i plus 7i makes plus 9i. Just a little bit more complicated. So here I'll just bring this one down for a second and work on these inner parentheses. So this is going to be addition, so 3 plus 2 is 5, and then negative 5 plus 3i would be minus 2i. And then I'll drop the parentheses and distribute that sign. So that will make a minus 5, and minus a minus makes a plus 2i. And then collecting terms, I'm going to get 4 minus 5, so that's negative 1. And then minus 7 plus 2 would be minus 5i. And then for this one, I'll go ahead and distribute that sign. So 3 minus I, and then that makes that a minus 4 and a plus 5i. Might as well distribute that sign too, so that'll be a minus 7, and then minus a negative will make that a plus 3. And then I'll go ahead and collect in here and then put these with it. I guess I don't really need to, but I'm going to. So this would be 3 minus 4 would be negative 1. And then minus I and plus 5i would be plus 4i. And then here, I probably should have just left that in the parentheses, but I already had distributed, so there it is. So now these parentheses aren't really doing anything, so I can just collect them. So negative 1 minus 7, so that would be minus 8. And then 4 plus 3i would make plus 7i. Okay, and then this page is the matched problems I'd have you guys try in class. So 3 plus negative 5 would give us negative 2. And then negative 7 plus negative 2i would give us minus 9i. This one, so let me rewrite it with the subtraction. So 6 plus 4i, and minus that negative will make it a plus 1 and a minus 2i. So 4 minus 2, sorry, 7, let's do the real part first. 6 and 1 would be 7, and then 4 minus 2 would be plus 2i. Down here, I'll go ahead and distribute. So 6 minus I minus 2 minus 5i, and that would be just plus this stuff. And so collecting this, I get 6 minus 2 would be 4, and then minus I minus 5i would be minus 6i. And now these brackets aren't really doing anything, so I can just drop them. And it's plus this one, and those parentheses aren't doing much, so I'll just drop those two. And I have 4 and 5 would make 9, and minus 6 plus 4 would make minus 2i. And then this one, pretty similar. So this would be 5 minus 2i minus 3, and then minus and minus make plus I right there. Just leave that for the moment. And putting these together, 5 plus 3 would be 2. I'm sorry, 5 minus 3 is 2. And then negative 2i plus I would make minus I. And I'll go ahead and just bring that down for a second. And then to clear the parentheses, I'll go ahead and distribute. So 2 minus I minus 5 minus I. So 2 minus 5 makes negative 3. And then minus I minus another I makes minus 2i. Okay, so then we get multiplication. And pretty much it looks like FOIL, and that is exactly what it is. And so we just do the same steps we would as if we were foiling. So 1 times 5 would be 5. 1 times 2i would be plus 2i. And then 3 times 5 would be minus 15i. And then minus 3 times 2 will make a minus 6. And I times I will be I squared. And then on this next line, I'll collect terms. I'm going to simplify that I squared, because remember that I squared equals negative 1. So what that's going to do is be 5 plus, 5 minus 13i, because we're going 2 minus 15 for minus 13. And then this is minus 6 times a negative 1. So that flips the sign pretty much is what that I squared is going to do every time. And it's going to make this a plus 6. And then I'm not in A plus BI form yet, so that means I can do a little bit more. So 5 and 6 would make 11, and then minus 13i. For this one, so this is one of those ones of the form A plus B quantity squared. And so I can do this as A squared plus 2AB plus B squared. And so I'm going to show it that way. If you don't like that, just write it side by side and just do this, and that will work. But if you got to take a lot more math, you really want to get comfortable with this, so I'm just going to keep doing examples this way. So this would be 7 squared, because that's like my A, plus 7 times 2 times 2, so that'd be 28i, and then plus B squared. So I'm just going to write that as 2i squared for a second. And I'll get this cleaned up. So this will be 49 plus 28i. And then this will be plus 4i squared. But remember, I squared is negative 1. So that's going to flip that to a minus 4. And then combining with the 49, that's going to give me 49 minus 4. And that will be 45 plus 28i. And then down here we have complex conjugates. So we saw the conjugate pairs. To clear the denominators, couple sections ago. So this one is the complex conjugate, and this is why a squared plus b squared never factored, is because it has these complex solutions. And so I'll do this one out and then show the shortcut for it. So if I did the FOIL, I'd get 5 times 5. I'm going to write that as 5 squared for a second just to make it look like the thing I'll do in a minute. On the outside, I'm going to get minus 15i. On the inside, I get plus 15i. And on the end, I get 3i times 3i. So I'm just going to write that as in mixed signs, so minus 3i, and it'd be quantity squared. So these cancel, and then what happens here is this is going to be 25, so that was my a squared, and then this is going to turn into 3 squared would be 9i squared, but I squared is -1, so that flips the sign to plus 9, and that's my a squared was 5. B, notice that b isn't 3i, b is actually just the 3. And so that gets me this 9 down here, and then adding together makes 34. So if I do this the short way, rather than all that mess, and that's definitely, if you don't like this, that's cool, but if this one you should like. It's just 5 squared plus 3 squared. You don't even worry about the I because the plus in the formula catches that sign change. And that's our 25 and 9 for 34. So for this one, this is the little bit sneaky. A good way to think of this is 4, because if you ask what someone, in class when I ask, okay, what's B, everyone says I. B isn't I. B is going to be that invisible 1 in front of the I. So it's like this, and 4 plus invisible 1, I. So when I go to do my a squared plus b squared, I'm going 4 squared plus 1 squared, not I squared, because then that flips the sign and then goes the wrong way. So 16 and 1 would make 17. So this one, 7 times 3 would be 21. 7 times 2i would be 14i. 5 times 2 would be minus 15i. And then 5 times 2, so that'll be minus 10i squared. And then combining and simplifying, I get 21. 14 minus 15 leaves minus I. And then this I squared is -1, so that flips us to a plus 10. And then 21 plus 10 will be 31 minus I. Here, I'll do the a squared plus 2ab squared thing. So that'll be 6 squared plus 2 times 6 would be 12. And then times 3 is 36i. And then plus 3i squared. So that'll be 36 plus 36i plus 9i squared. But that flips the signs, that makes that a minus 9. So it'll be 36 minus 9. So I'll leave 27 plus 36i. Down here on the conjugates, hopefully you're just going to go 3 squared plus 2 squared. It's that easy if you got conjugate pairs. So 3 squared would be 9 plus 2 squared 4, or 13. And this is the one where you have to just be a little careful with the little invisible ones in front of those eyes. So this is 6 squared plus 1 squared, or 36 and 1 for 37. Okay, so then we have division. And this is a lot like the problems we saw back in, I think it was 8.4, where we had stuff like 3 over root 5 minus 2. And then the trick to these was to multiply by the conjugate to go root 5 plus 2, root 5 plus 2. So this is the exact same idea, it's just the conjugate now is going to be the complex conjugate. So you kind of want to tie these two problems together in your head. So when we're dividing where there's addition or subtraction, we use the conjugate. And we're dividing complex numbers, we're going to use the conjugate. So for this first one, I'm going to multiply it by 4 plus 2i. So same stuff, just the opposite sign in the middle. And that top becomes a distribute, so 3 times 4 would be 12, and then 3 times 2 would be 6i. And then downstairs, we can just do our a squared plus b squared. So 4 squared plus 2 squared. So that will be 12 plus 6i over 16 plus 4. So that is 12 plus 6i over 20. And the same way we ended up reducing these is what we're going to do here. I like to think of it as I'm looking for what's the biggest number that divides into all three of these. I could write it with two separate denominators, but I think the way the computer wants it is over a single one. They're both correct. It's just two different styles. So since we're looking for this version, the biggest number that goes into all three numbers is going to be 2. And so I think of it as 2 goes into 6 3 times, 2 goes into 12 6 times, 2 goes into 20 10. And so then my final on that will be 6 plus 3i over 10. This one, same idea. We're just going to multiply by the conjugate, which is 5 plus I. So then we got some FOIL up top. So we'll do 2 times 5 for 10, 2 times I, 6 times 5 with an I, so it'll be 30i, and plus 6i squared. And that will be over 5 squared plus, it's that invisible 1 again, squared. 10, putting these together we get 32, 32i, excuse the blob. And then this flips to a minus 6. And that'll be 25 and 1, so that'd be 26 down there. And if I finish combining, 10 minus 6 will give me 4 plus 32i over 26. And everything is even, so I can knock a 2 out of there. So 2 goes into 4 twice, 2 goes into 32 6 times, and 2 will go into 26 13 times. So then my reduced form is 2 plus 16i over 13. And these last two are the ones I would have you guys try. So this first one will go 4 plus 5i. So that'll go, let's see, 3i times 4 would be 12i, and then 3 times 5 would be 15, and then I and I for I squared. And downstairs we're going to get 4 squared plus 5 squared. And so this would really be a negative 15 because of that I squared, so I'm going to write it in the opposite order. So negative 15 plus 12i, so it's a plus bi. And then downstairs, that is 16 and 25, so that should be 41. I think that is as far as you can take that. And then over here, we're going to do 3 minus 4i. So 2 times 3 would be 6, 2 times 4 would be minus 8i, and then I times 3, so 3i, and then times the negative 4i would be minus 4i squared. And that's going to be over 3 squared plus 4 squared. So cleaning this up a little bit, I got 6 minus 8 plus 3 would be minus 5i. And then that's going to flip the sign on that minus 4 to make it a plus 4, because that's a negative 1. That's over 9 plus 16. I'm collecting my like terms, so 6 and 4 for 10, minus 5i, and that's over 25. So it looks like I can knock, I can reduce a 5 out of everything. So we'll go 5 goes into 5 once, 5 goes into 10 twice, and 5 goes into 25 5 times. So this would be 2 minus, we don't usually write the 1i, so I'll just call it I, but it's that invisible 1. over 5. And that concludes complex numbers.